Example number 2, examining the relationship between a conditional statement and its contrapositive. Consider the following conditional statement. If a number is a multiple of 10, that's our hypothesis, then it is a multiple of 5. So here's our conditional statement. So A, write the contrapositive. We know that this is P, this is Q. So the contrapositive is not Q implies not P. So that means if a number is not a multiple of 5, then it is not a multiple of 10. I'm just going to color code here just to show you. The hypothesis becomes the conclusion of, needs to be negated and becomes the conclusion of the contrapositive. And the conclusion of the original statement becomes the hypothesis, but we must negate it for the contrapositive. So verify that the conditional and the contrapositive statements are true. You're going to find this relationship all the time. The conditional statement and its contrapositive is always going to be true. Let's check it out. So if a multiple is if a number is a multiple of 10, then it is a multiple of 5. So let's think of some multiples of 10. 10, 20, negative 50, 70. All of these are multiples of 10. So we start with a multiple of 10, and all of these are actually a multiple of 5. So this is true. The way that we could express it as a Venn diagram, we can say that all the multiples of 10 are held in all the multiples of 5. We would say that this, the number of tens, is a subset of the multiples of 5. So if a number is not a multiple of 5, then it is not a multiple of 10. So I'm thinking 37. Oh, I should say conditional true. Or P implies Q, true. 37 is not a multiple of 5, and it is certainly not a multiple of 10. So the contrapositive, which is not Q implies not P, is true. It's worth noting here that this is not a full proof that proof or verification that it is true. It's kind of unfair. You just need one counterexample to show that a statement is false. But I would have to go through, using this method, I would have to go through every single number that is not a multiple of 5 and to see if it's not a multiple of 10. So what we've done here is we've just made sense of it. However, it is not, you shouldn't think that this is a full and rigorous mathematical proof. But it's good for what we need it to be.